Hello and welcome to this Automation Academy Mastering the Machine video for November 19th, 2021. Our guest today was Ted Thayer from Phoenix Contact, and we discussed the PLC Next platform and its software. Hope you enjoy it. So this is actually the 26th Mastering the Machine webinar for this year. We do them every 2 weeks. And that means we have done them for 52 weeks, which is 1 year. And today's topic is PLC Next, and we have Ted Thayer on from Phoenix Contact to explain what PLC Next is, talk about the platform and the software a little bit. What is Mastering the Machine? This was named after a document that I put out almost, I guess, 7 or 8 years ago. Anyway, it is available for download at these two websites, which are my websites. One's a blog, one's a company site. And under that company site, there is a thing called the Automation Academy, which has evolved into a training and automation website. And we mostly cover things like system integration, but there are a lot of PLC programming videos on there and that sort of thing. So this is the birthday of the Automation Academy. We opened 1 year ago, and my first guest was Phil Scruggs, who is on with us also right now. He was one of the early members, and so we just kind of talked about what the Automation Academy would be, and it's already been 1 year, and we've done 26 of these. I see John joining also. John, hello. And so what is the Automation Academy anyway? Opened a year ago. We have training videos for mostly Allen Bradley, Siemens, and Omron. And I really hope to create some videos for PLC Next. I need to become a lot more comfortable with the software before I do that. So hopefully I'll learn some more tricks from Ted, and of course, some of the documents that Ted sent me showing how some of these things work. We also have a community with interest groups, a library of training and technical documents and software, and we have regular events. We do this every 2 weeks, Mastering the Machine webinars, and this is the website where, if you're interested, you can read more about it and sign up. Our guest today is Ted Thayer, and Ted Thayer is from Phoenix Contact, and here is a lot of his information. We were talking a little bit before this show, and he mentioned that not only he has an MBA, but he's done the PMP and other things and technical things. So he didn't put all the little letters after his name. But if you've ever asked yourself, can my machine do more, or how can I move from where I am now to where I want to be? Ask me. Ted is an automation technical professional, as you can tell by the big wrench in his hand. Good technical professional should always have a wrench, although that is one of the biggest I think I've ever seen. I would say that probably weighs quite a bit. So this webinar brought up my interest in PLC Next, because I've actually borrowed one of these from a couple of the people that are attending today. I see John Wagner on here, and John works for Gray Bar in my local area. We actually kind of have some things in common over the last few years, and we met up, and John brought me a PLC Next trainer demo that looks more or less like this. I may kind of show a little video of this in the middle of the webinar kind of, and I see Vlad holding one up also. Vlad has, I think that may be an older model, yeah, with the big logo. Very cool. So a little different, but there's another demo. So I say rare and elusive because these are kind of hard to come by. I immediately wanted to order one, and I talked to John about it, and he said, well, they're kind of hard to get right now. So they're trying to put me together some bits and pieces. And of course I can maybe make my own backplane and things like that, but things even like these, the little potentiometer that's shown here, maybe some of these things in the switches, I think, are kind of hard to come by too, but those are kind of neat. So at this point, I think I'm going to turn this over to Ted, and let him kind of talk about the platform. Good morning, Ted.
Yeah, good morning, Frank.
I'm going to go ahead and turn the share over to you. Look at all those happy faces there. Vlad, you see the big demo there behind Vlad. So I don't see the PLC Next on the wall yet. Is that in process? Oh, it is back there. Okay.
I've got a couple. The trainer, I've got it on my desk just because I wanted to keep it as is. But yeah, I've got another one behind me that's not powered up, but should be pretty soon.
Very cool.
Yeah, he's got one of the new style there. Impressive. Those have been especially hard to get.
Okay,
yeah,
that's
the black ones are the new ones. What you've got there is an example of the I hate to use older. They switched the IO technology, which we'll be talking about a little bit during my presentation.
Okay.
So,
well, go ahead and grab you should be able to grab the screen there. There we go.
All right.
Cool.
So are you looking at a guide contemplating the infinite galaxy of possibilities?
Absolutely.
Awesome. All right, then. So once again, I have shared successfully. So, all right. Yeah. Ted Thayer, strategic engineer for Phoenix Contact. Also on the side, when I'm not working for Phoenix, I do teach a nighttime college class in engineering at a nearby engineering school. The big wrench comes in handy for making sure the students, I have their attention and they don't nod off on me. 6:39 could be a tough time to teach, but that's what works for some of them. So anyway, what is PLC Next? If I only had 3 minutes, I would just show this slide and say it's essentially a Linux computer inside an industrially hardened PLC format, essentially. So, it's a Linux computer. We do have our deterministic runtime engine on it. And so if you just really need a really fast PLC, we can absolutely do that. However, we have cracked open the OS. A lot of PLCs, it's proprietary, what's running on there. We make it wide open to you. So as a result, you can kind of go and do different things with it if you want to. You can run almost any software on it. It is IoT ready. We have hooks into the cloud, to the internet, to remote devices. So that makes it an ideal, pick your acronym. If you're looking for edge devices, implementing Industry 4.0, if you need a gateway, you can do that. So the fact that it runs on Linux does open up a whole universe of possibilities. As I kind of highlight over here, just a quick poll of people who have their cameras on, anyone familiar with the mGuard Phoenix Contact product? Nope, not really. Yeah, it's always curious. I'd like to ask. The mGuard has been around for 16 years now. It's like an IT super security fortress, protecting networks. And we were doing it before it became a cool thing, before cybersecurity for industrial networks became a thing. We were doing it. So we have a lot of expertise in cybersecurity. And because the mGuard, which is our main product for that, was built on Linux, it was easy to port over much of the functionality to the PLC Next. So now we have a controller that can also defend itself quite well as part of a layered cybersecurity approach. So the PLC Next is also IEC 61131 compliant. So, if you've had an experience with Codesys, for instance, or maybe, Omron's, what's their CX developer software, it means you can use things like descriptive names for your IO. You don't have a ladder of X's and M's and N's and O's. You got start button, high level, what have you. It also means that you can make your own instructions, which we'll be showing a little bit of that. And it also means you have some choices you can make in your programming style. You're definitely not stuck with just ladder and only ladder, for instance. So with a device like this, which is being billed as an edge device, Industry 4.0, one of the options is you've got a future-proof, and you need to be able to run whatever programs you need to handle data concentration, or to do data analytics, or to process information. And the way PLC Next achieves all that with the Linux OS is that we can We have many different languages or programming styles. If you prefer doing ladder, that's this icon right here. We can do ladder. Our ladder software is free. You just download it. We post regular updates to our website, and so you can program in ladder. If, however, you prefer Python, or you've developed stuff in MATLAB or Simulink, or maybe you're a C++ guy or Node-RED guy, we can run programs developed in those softwares as well. So in some cases, say C++, C++ actually underlies our whole system. So our logic engine, our IO backplane is C++. So if you're not a ladder guy at all, and you want to do up your whole program in C++, go ahead. You can do it. We've got the SDKs on our website that help plug in, give you profiles for the different IO modules, and you can do that. However, I think the greatest power comes into play in the fact that you can use all of these different technologies together. So you can use ladder where it's important and effective, or you can use Python or C++ where it would be effective, and you could use them together. One of the favorite applications I've been having the privilege of working on some is a warehousing system for a company. They're building warehouses, with conveyors and pick and place, and there's a general map that they try to follow. The thing is that map with the locations and all the different product codes, I believe SKU is what they call that, there are literally millions, and no PLC by itself could possibly hold all that information in. But what they were doing with the PLC Next is it's running the conveyor system, it's reading the barcodes as packages go through it and get scanned. It's taking that part number, moving it out of ladder into the Python code, and then from there, it's using MQTT and talking up to a cloud. I believe they're using AWS. They kind of store the master part code list as well as the map location, and it sends the information back down to the PLC, back to the ladder, which then starts directing and diverting the package where it needs to go. So a very cool application. One of the first things we got to work on, and just sort of one of the first things for me to say, wow, look at the power that this thing has. So if you're more of a software development type person and more of a software engineer, you might be excited by the Docker icon here. We do support Docker, which is, it's kind of an industrial virtual machine platform. And what that means is someone developed code for a different version of Linux. Ours is Yocto, by the way, if anyone wants to know. Say someone developed something for Ubuntu or Red Hat Linux, and they want to port it over to us. They can actually stick their program, their work inside of a little Docker package, drop it right in, and start running their code with relatively few modifications. You have to open some ports in Docker to access our IO and stuff. But say you develop something for a Raspberry Pi, say you develop something for an embedded controller in Java that you've been using for years, and you're like, man, I'm tired of sourcing the parts, man. I really need something more industrial. You could port your work over to the PLC Next and not have to rework it from scratch. I'll admit, before I started this job a couple of years ago, I'd never heard of Docker, never heard of Node-RED, never heard of Python, but it's just impressive the things that we've been getting into. So I just like to highlight Node-RED a little bit because, like I said, some of these languages I hadn't heard of before I started in this role. When I went to engineering school more years ago than I'm going to admit here while being recorded, I learned C, I learned Fortran, I learned assembly, and I learned a little bit of COBOL. So those are the languages that I've learned, and I've been basically a ladder programmer now for the last quarter century. But Node-RED has been a fun language to start learning because it's free. You develop it in your web browser, and it's a very graphical language. You kind of draw your charts, kind of fill in the boxes with some code, and then you can go to town. And Node-RED has been a very collaborative environment. Before we put Ethernet IP into our processor platform, we had found an Ethernet IP library on Node-RED. It was a coworker and I at a trade show where we were just getting a little bit bored. And we grabbed this library, popped it in, and in about 15 minutes, we had Ethernet IP running on our controller. So it's just amazing. Since then, we've gone back to get BACnet. We don't need it for Modbus, but some people prefer this Modbus over our function block version. If you want to implement MQTT, if you're wanting to parse and store data using MySQL or whatever. Node-RED has just been a very fun language for me to play with, and one that I see is being pretty widely adopted by many of the companies that are adopting us because it's so easy to build these cloud connections. They're using us as their gateway from other systems that they're running, primarily on Allen Bradley, and using us as the gateway to get information up to the cloud. So just a very interesting language for me to start learning. So another thing, if you're going to be putting in a device for a long time, that's going to act as like an interface between the OT side of the factory and the IT side of the factory, you're going to want something that's got future-proof connectivity. Any of us who've been in this industry for a while, when they put in a PLC, they kind of want it to run for years, if not decades, without being disturbed. I used to work for Mitsubishi, and occasionally I would get tech support calls on products, PLCs that we discontinued at least 10 years before I started there. So, longevity in machine control is great, but as we have seen in the IT world, things move a lot faster. Even since I've come on board here in the last 5 years, 3G is given away to 4G very quickly, and now there's 5G products out there. It's the industry is changing very rapidly. 10 megabyte Ethernet data transfer rates were pretty typical when I started, if you had Ethernet at all, and now we're talking gig speeds, so you really need a hardware that could keep up on the IT side. And fortunately, we feel that with the Linux OS, combined with our ability to tap softwares like Node-RED for drivers, we have been able to keep up quite a bit and speak a number of different languages. Another interesting feature about PLC Next is this ability to store what I would call an eHMI, internal HMI program inside the PLC Next. For those of you who are more technical oriented, and know about web technology, essentially we have a web server called Nginx that runs inside the PLC Next, although you could replace it with something else if you want to. That's what we put in there. And so you can make a program that's HTML5 compatible and run it in here, and then you could display it out to whatever kind of display device you want. Could be a PC, it could be your smartphone, an iPad, it could be a web panel, which is a device that we sell and a number of other people do. It looks like an HMI, but it's actually runs the program stored in the PLC. It doesn't have its own software. So the upshot of this is, if your hardware breaks down and you need to get an HMI off the shelves somewhere, and due to chip shortages, if it's going to be a little while, you could plug in your laptop and limp along if you had to. It's also easy for a technician to replace. They just plug in, power up, point the display device at the PLC, and it takes the program and starts running it. So it definitely minimizes maintenance issues. And because it is a web page, it will display the same on a web panel, on a PC, on a phone. It's the kind of thing I like to show whenever I'm teaching. I have a program that's displaying to a web panel, and I've got it displaying to my smartphone, and I can plug in my PC and bring it up, and it looks just the same in each medium. So as an additional bonus, we do include the HMI tools inside our programming software. But if you prefer, say you used to build web pages as a teen and you're really good at it, you can build your screens in whatever you want, Java, C#, what have you, and then you can use that as well. So I've talked about being IoT ready. we have the tools already pre-built to talk to any of a number of different clouds. And these tools take a couple different, what's the word I'm looking for? Formats. You can, we have ladder code that can do it. We've developed little applications in C# that you can put it on there, or we've got full-blown applications you can download off of what we call our PLC Next Door. And so you can connect up to any of these clouds, or if you have something private that your company wants to do, maybe they've made a deal with Oracle or someone to host their own cloud, we could talk to that as well. It's not hard to do. We've got a lot of expertise now in building those connections, especially because we do support MQTT, and that tends to be the baseline. So the Profi cloud, if you hadn't noticed this cloud over here, and I've heard of these, what the heck is that? Profi Cloud is our cloud. It's one that Phoenix Contact has developed. Nothing to do with Profinet or Profibus, other than it's just a well-recognized prefix in Europe. So Profi Cloud is our cloud. We have it built right into the PLC where you check some boxes, download a certificate, and then you're taking data and you're logging it up. And our cloud as well has built-in tools to do your dashboarding. If you've put data on a cloud, usually the dashboarding, the visualization is another separate project. We do have options to just make it drag and drop and point and click, and then you're storing data into a cloud and looking at it. So the PLC Next Door and community, that is something I kind of referenced to before. We have an entire online support group. So there is, the community is a forum posting questions, answering questions. Many of our Germans in our development group keep an eye on that page. And so you could get questions answered from the highest levels. There's also a maker blog where people post interesting applications. Hey, I've developed some software that your IO can be completely dynamic. You can plug in what you want and the software will pick it up and you can run a program. You don't have to declare it ahead of time. Or, I've done some work with OpenCV and now I've got my controller working, controlling a vision system. Here's the code that I did it. A nice sharing space that shares a lot of information. On top of that, we've got the PLC Next Door, which is kind of our version of the Apple Store. So companies develop libraries, they develop specific runtimes or special programs, and they post them here and you can download them and use them. Some are free, some are something that folks charge for. It just all depends on the programmer, but Phoenix Contact carefully vets everything before they post it up here. So that way you know what you're downloading and using has been checked out and not going to hijack your system. And we usually ask for a certain minimum level of documentation as well to make sure that someone who accesses these programs can make use of them. So some applications, just a very general reference to how this has been used. Of course, PLC Next can do machine control. As a high-level controller can do machine control and then feed information where you need it to. A second popular application has been as an edge device. We're in the United States, so I'll just admit it. Everybody uses Allen Bradley, right? And then you've got a pretty high number of Siemens users, Schneider users, Omron and Mitsubishi, kind of in that order. We've got the tools to talk to any of these third-party devices, and we are that edge device where we could store information, run basic analytics, whatever you need, and then feed that back down or send it out to the cloud or to the SAP or ERP system. So we can do that. And then finally, we've got the horsepower and the capability that we can do both, function as a machine controller and as an edge device, which as I've been learning, a feature Shangri-La for Industry 4.0 is to being able to do digital twinning, doing an exact virtual replication of your process in a cyber environment so you can check changes and see how things work. What better device to feed your digital twin than the device that is actually running the process? So there have been some very interesting opportunities as companies have been exploring that possibility. So just a little bit about the hardware, and then I'm going to be done here. The basic platform consists of 3, sometimes 4 products. We do have an RFC 4000 series, which is a real monster that sits up here. That's a quad core controller with massive safety capabilities. But most of my day-to-day is with the 1152, 21, 3152. And in interest of time, I normally go through a bunch of slides in the hardware. We can get back to that later if there's the time and you're interested. But just to give you an idea, the 2152, which is kind of the mid-range product, is it's got built-in 512 megabytes of RAM for running your programs and doing data storage. There is an SD card you can slide in there, and you can bump that up to 32 gigabytes of data. And then if there is an HMI or a web panel or some device like that, we could also access the USB port and a USB stick, and you could do, an awful lot of data kind of off PLC if you want to do that. So it can talk to 4,000 IO points on the right-hand side, the local bus, and then they're, through Ethernet, Profinet, which is our primary bus, we could do 64 stations of IO off this thing. If you do the math, you could do a couple 100,000 IO points, mathematically speaking. Practically speaking, with IO traffic and such, we've kind of found that 12 to 15,000 IO points, kind of the high end for this controller, which really isn't too darn bad. Dual core chipset in here. It's an ARM chipset. And we have the ability to add left-hand modules, which are special function modules. For instance, the most popular one is an Ethernet module, which gives you an additional Ethernet port. There are 2 that you can't see. Gives you a third one, separate NEC card, so it can sit on a separate network, separate subnet. So you could kind of enhance your network security by having 2 isolated networks running on the same processor. 1152 can do all the same stuff. It can run C, talk to the cloud, talk to 4,000 points of data of IO, up to 32 gigs of memory. It does not have a left-hand bus. And then it can do 16 points of IO, or 16 stations of Profinet remote IO. So it's a somewhat stripped down version, which is what we would use for if someone wants to step over from a Raspberry Pi or a custom controller they've been developing for a while, a little more price sensitive. And this one is 2.5 times the power of this one. I won't get into all the stats right now, but it's a real monster in terms of capabilities. 3 network cards, for instance, and it does gigabyte speeds. So getting down to my last couple of slides, any kind of a controller needs IO in order to impose its will on the machine. And so here we've got 3 different IO platforms that we can run on the controller. This one here, the Axial Line F, is kind of your standard IO, highly configurable, very dense. It's got push-in technology, so you don't have to do screws or even ferrules necessarily. You can either, if it's ferruled, it's easy to push in, or you can push on a little orange tab with a screwdriver and slide in even unferruled wires. So easy, quick connect. Axial Line F is the smaller stripped down version of this. So each module is actually a very small slice of IO. Can be up to 16 points though, depending on the type of IO module. And these are actually bases that snap together, and then you push in the IO that you're using. So just to give you a feel for size, with something like this over here, it probably have 16 to 20 IO points in this space. In the same space over here, you could have 96 IO points. So you could have a very compact controller with a lot of IO. The inline here in the middle, if anyone has been working with Phoenix for a while and are familiar with our ILC, our little green monsters, this is the IO that's been around forever. So very large installed base in the US. And so we've decided to make this connectable to the PLC Next as well. If someone needs the power of the controller, but doesn't really want to have another IO family to stock or support, we've given you that option. So yeah, just kind of the last slide here. This is one of my boards, which I believe Vlad has the same one. I laid a ruler down here just for kicks. This is one of the 4-slot IO bases. Again, you can add additional bases, do up to 64 IO modules, but in a 3¼ inch space, you could have a Linux controller and you could have 64 IO points all in that one little space. So a lot of power in a compact area. And the 6-slot base adds just another 1/4 inch. So you do that, 3½ inches, you've got a Linux type controller and 96 IO points capable in that small area. So very interesting stuff. And what I thought I would do next here was kind of open up the software and show a little bit of that to you, unless anybody has any questions they want to fire off right away or while I'm opening it.
Does it have AC modules and high-speed counters and things like that, typical PLC stuff?
Yeah, high-speed counters, yes. Weigh scale, load cell, thermocouples, RTD, encoder modules. I will admit, having said all that, ACIO is not our strongest suit. Being a German company, they have been largely trying to get away from ACIO over the years because of safety concerns and considerations. So we have ways that we can do that, but I will admit, if you're having a very large AC-based operation, we probably should talk about a little bit first how we would go about that. So are you guys seeing my software right now?
Yep.
Okay. All right. So this is when I just opened it up. This is kind of the base screen. And of course, like any software, you can jump off here to the left and select something you've been working on. The way I prefer is to select software on your templates. And so what this does, if you select a template, it kind of creates a wizard that runs behind the scenes. And so it's going to lay out your platform, your workspace as it is, and it does a few things. It pre-creates a few things. It makes a few assumptions about your IP address and stuff, making assumptions that you're programming a controller right out of the box. So what you can see here is you've got the plant, the watches, your workspace, and your components. So the plant is basically, not always, but general rule of thumb, if you're going to make hardware changes or work with the hardware, that's over here. Most of your programming can be done over here. And then the watch windows are all the different windows that show your errors or you can use for monitoring and that sort of thing. So, starting from scratch, the first thing I would do would be to come over here and start selecting the IO that I know I'm going to be using. So you got your Axio line F, that's the plane. And so if you go here, then if you kind of know what you're looking for, it's pretty easy to go through it alphabetically or to search for it. My particular demo's got a combination module for digital and it's got a combination module for analog. So you can do that, or because we believe in options and choice, you've also got everything all the way over here as well. So you could go and select your different IO and drag and drop it and bring it over. So that's the way you used to have to do it. But since they put in this table, I just find it a lot easier to use. So when you go to one of these IO modules, notice that you can have some different options for a digital IO module, some different settings you can change, like your filter response time, what to happen if there's an error in the PLC, what you do with your IO, and then the way that you tag your physical real world points to your to your PLC program, after you create tags, you can just go fill them in here. And so that's kind of how you connect your physical IO to your PLC. And then with the analog, same type of thing. You have some different functions. There's some parameters, with our analog modules. These are configurable, so you can pick what style of current you're going to reading in. You can make those changes, or you can make something inactive if you want to. You kind of do that tweaking here, and then there's your list for connecting your real world IO to your PLC program. So as far as the programming work happens over here, under the programming, main tends to be where your action is. And when you select it, you get your choice of, do I want to program in structured text? Do I want to use what the Germans consider to be ladder, which is really kind of a form of function block? Or do you want to program in what Americans would consider ladder, which is NOLD stands for network oriented ladder diagram thing. So I'm actually more of a programmer like this, even though I am an old style programmer and I like my ladders. I have come to like the flexibility that you get from this style of programming. So my personal preference, but you've got your ladder here, and then you could start, putting in your contacts and your coils and your branches and your branches. And so you can start building a ladder and laying it out, but we also have a lot of shortcuts. So for instance, if I just click here, notice you got a little icon up here. There is a quick way to build a ladder right there. Or if you have instructions you want to do, moves and adds and that sort of thing, you can just kind of start typing things right in and then start filling them out right then and there. And so the red is because I'm creating ladder on the fly and I'm kind of creating tags on the fly. But as you do that, you usually have to take a moment and specify something, so, but just kind of trying to show quick and easy, how things happen here. I'm going to make this a variable and then eventually start using it. So I don't know, I could show you the ladder. One of the couple of tricks that I was showing Frank yesterday, when you click on a contact, for instance, it wants me to make it a variable. So we'll do that. Notice you've got some different icons here, where iterate through the types. I can go from normally open to normally closed to rising edge pulse, falling edge pulse, back to normal again. Or, if I've just dragged a few of these, a copy and paste, and I want to change something to a coil or back, you can flip through that easy enough. Over here are some different documentation things that you can do, which are pretty cool. Here, you sit on a coil and you start clicking through the coil. Now it's a reversed operation coil. So it's opposite state of a standard coil. There's your set. There's your reset if you want to do sets and resets. And then you can pulse it, rising edge pulse on, or falling edge pulse. So you can kind of step through your different coils in that way. So, there's just kind of a lot of tools to start getting used to here. You just have to start playing around with the software. So, but over here on the right-hand side, I said, if you add, you've got timers, you can just type them right in. If you're not sure what it is that you're looking for, then, all the different instructions are over here. You do have to kind of click through the categories and find things, but you can do that, or you can do a search up here. And I want to really and something, and then it'll pull up your and instructions. Oh, data handling, not what I was looking for, but why not see what's in there? So the trick with this is you do have to eventually remember to turn it off. Otherwise, it keeps restricting what you can see. So that has frustrated a few people until they've called me. So something that I think is pretty cool about PLC Next Ladder, normally maybe to make your programs compact and easy to read, you tend to have a program to do this, machine control, sequence, averaging, alarm handling, something like that. And you can certainly do that here. We can certainly add programs and do that. However, in PLC Next Engineer, we support this thing called code sheets. So this little plus up here, I can add an NLD code sheet if I want. And now I've got, I could start writing my code here and start building code here. Or if I'm like, man, I got to do a for next loop. And boy, it's just kind of a pain to do in Ladder. You could create a separate code sheet that's based on structured text, and then insert your templates to do for next or whatever. Try that again, insert template. There you go. And so you can have your code running together in different code sheets, and you could give these things names up here. I could name this, name this, name this, and I could keep building that. But I think I'll just kind of show you an example of a program that I've been working on. So yeah, this program here, I'm working on a fire protection system where the PLC is reading a camera that's reading temperatures, and then it's essentially maneuvering a hose that dispenses the fire retardant propellant to put it out. And so this here is an example. There's an HMI in here that's got some controls that's built into it. But over here, so here's kind of an example of code sheets. There is just some initial code. This particular device, the hose that it's talking to runs off of CAN. So these are some blocks here from a CAN library that we developed that are reading the CAN information and bringing it in. And then there's a separate code sheet, again under main. Notice it's called parsing data. And this is a structured text program. This was a way, we just found this to be an easy way to kind of take the CAN information, which is coming in arrays, and just easily breaking it out and assigning it to tag names. And then here's a separate code sheet also inside of main, which is running the primary targeting algorithms. So there's a block here, a pixel convert. It's reading the FLIR camera, taking the highest temperature location, the pixel, and converting it into a set of coordinates that the other device can understand. So, there could be multiple cameras, so there's camera selection going on. There's the targeting system. There is some extra plain old regular ladder here to allow the operator to override the manual. And then here's a series of blocks that are, again, allowing manual or auto selection, and they set your speed. So this is kind of a ladder here. And then there's a separate ladder here that governs the camera read, which is being done by Modbus TCP. And so these are all separate programs. They're like subroutines, I guess. It's a subroutine you don't need to call, and they kind of run in their order here. And so I just like the fact that with these code sheets, you've got a program main, and you can write your sections of code in the way that makes the most sense. Now, what Frank was kind of talking about, which I have included in this program here, is, for instance, auto target. This is a function block, and I can reuse it over and over again for different systems. But behind the scenes, it is actually an instruction that I built. So you can notice over here on this side, this kind of lets you zoom in and out. It also kind of gives you an overlay of the program. I compare it to the old days, the Battle Zone tank game I used to play, where they kind of show you the big picture here, but then your tank is looking here. I kind of like that. It kind of shows you that. And so here's this whole program that I developed that handles the auto targeting. But rather than using this code over and over again, I assigned it input variables, enables and such. There is the outputs like the speeds, so inputs and outputs that go into this thing. And that all together then creates this block that you can use over and over again. So I have kept these blocks that I've made as part of the program. That's going to be the property of the final customer. But I could, if I wanted to, say I'm this company and I make these blocks myself, and they probably will do this, you can actually create a library of instructions that you could share with someone if you want to, and it's just the function blocks. You can give them to your programmers, but they don't have access to the code underneath. It's just as unbreakable as a timer or a counter type instruction is. So that's kind of the real power of PLC Next, being able to make your own instructions. And Phoenix does that quite a bit, as a matter of fact. And that's part of the power of the PLC Next Store, is the fact that you could go to the store, and right now it's being covered by my icon. So that if, for instance, you're like, man, I want to do a little bit more with analog, you can kind of do a search and just see what's going on with analog. And oh, look, analog technology. Whenever you see this little fancy colored X, that's actually a set of instructions that you can download and add to your base programming software. We've created things like scaling instructions. We've created like frameworks for doing files, programs. I mean, there's a lot of different things that are here. This here is a pump control application that you could download, and it's creates a pump control. You can't really modify it, but if you're just looking to do basic pump control without writing all the loops and stuff, that's been kind of pre-done. But you can take these and download them, add them to PLC Next, just greatly expand your power. So just looking at the time here, I think I will stop now and look for any questions. I went a little longer than you asked me to. Sorry about that.
Oh, no, this has been great. It's awesome. Wow, I see a lot of familiar names here. Mike Cushman. That's haven't seen him for a long time. Mike's at Automation NTH, where I do some work. And Mike O'Day. Mike was one of the people that we've been talking about, possible use of this in the future if necessary, because it runs Node-RED, which Mike's doing some development in Node-RED. He showed us a kind of a neat Node-RED program a few weeks ago offline. That was cool.
Mike looks familiar. Have we talked before, Mike? Okay, I thought so. I thought so. All right.
Yeah, we did, Ted. How you doing?
Doing good. Doing good. Thanks for coming. You probably heard all this before, though, so sorry about that.
Always good to hear it again, Ted.
All right.
John Wagner.
Yes, sir.
So John is a resource for people if they need to know the pricing of some of this fun stuff, right?
Right, and I'm an application engineer working with Graybar in the Nashville, Tennessee area, and certainly love to talk about this. I've been doing this for a long time. Love to talk the bits and bytes, and as well as certainly we can help with the pricing, putting systems together. So love to work with you.
Great. And of course, Vlad and Dave are on here, and they have their own webinar and do tons of talk about different technical subjects and things also. And I can see Mike now.
Mm-hmm.
Cool. And all I see is Brian's steering wheel. I don't know if Brian's in his car, I guess. Any questions from anyone? Everybody's good. UDTs. So I imagine there are user-defined data types that you can also build in here, Ted. Yeah.
Yes, you can create those as well. The creation is right near where where the function block programming is. There's a spot there to create your own data type. So yes.
Okay. No questions? Anybody else? I guess, Mike, I didn't realize that you'd already talked to Ted, so that's good. You've gotten questions answered probably beyond what we would want to go here, so that's good.
Yeah.
All right.
Well, yeah, when you were talking a little bit about application you were working on, like, sounds like that one that I've talked to with that one guy about, but I didn't really want to say much due to discretion, but yeah, there it is.
So yeah, this is the elusive PLC Next trainer demo. John, I haven't heard anything about this. You had mentioned something about there are some, maybe in Germany or something, they are planning on getting some of these back out there again.
Yeah, they're working on it. What they're doing, Frank, is because the demand has been so high for the PLC Next as a product to use in a machine going to a plant, that they've temporarily suspended the sale of the demo units. So I'm working with Tyler and with Barry Crawford locally to put one together for you. So we're working that.
Yeah, I definitely want to buy one. This has been fun, and just sitting down with Ted yesterday, I think we maybe spent 5 or 10 minutes just going through the software, and I'm excited by the possibilities behind this. It's just so powerful. I mean, you can really build as big of an application, I think, as you want to.
Mm-hmm.
Yeah, it's definitely been exciting. I said Germany has started making some more of these kits, which is probably what you've heard. They're still pretty rare, but they committed to getting at least some of them out there. And they are going to be of this type here, which has the smart element IO, working reverse off of a camera. The smart element IO here, and it comes pre-built with a digital input, digital output, and an analog card. And then there's a blank spot. So if you had something you wanted to test, you could put it in there. I'm running an encoder card in there right now, trying to develop a program to figure out some encoder stuff for someone. So the new kits are definitely more flexible than what you've got there. Yours is pretty much hardwired, and you kind of really have to mess around with it. You're going to make a change. But since we've got the open slot, if you want to experiment with RTD or whatever, it makes it a lot easier to do that.
Yeah. One thing I liked about this one is this little switch module with the lights over here and everything is really useful for training.
Yes.
Because we use things with push buttons and lights a lot of times just to teach people simple coding. And this is all built into that. Whereas the one you have, I think there's some push buttons, and of course you can see the outputs anyway. But it looks like yours is a lot more flexible as far as wiring other things into it.
Right.
Right. Yeah, I would agree. The switch and the analog on that one are pretty nice. The switch is something that you can buy, that switch set. I mean, it takes a little while, but that is the standard product. The potentiometer is not a standard product, but we do have something called the IO exerciser, and that's actually the name, I/O exerciser, and that has it's a little bit of money. It's kind of expensive, but it does have 2 different types of analog on it, as well as a high-speed pulse. So it does come in handy for doing a couple of signal generations, whereas that piece there is strictly 0 to 10 volts.
So if someone wanted to just pick up the low end, the 1152, does anybody know about the price point of that? I think John mentioned that there may even be a lower end product coming out later that's competing with the Raspberry Pis and things.
Yeah, there's a number of different things being discussed. I mean, I know what the list prices are, but if you got a distributor on, if he wants to share what he typically charges, I leave that up to him, I guess.
Yeah, that's something. I don't know. Is Tyler still on the phone? Yeah, Tower's my pricing guy. So if
Oh.
anybody would like to get to some more details on pricing, just please get a hold of me and I'll work with Tower to get that quote to you.
And I'll put some links to people's LinkedIn connections if they want to contact people. John and I are in contact, or so people can connect on LinkedIn or by email or just by going to the Gray Bar site. Of course, if you're in the Nashville area, John's right here.
Right.
Okay. Well, our hour is just about up here. Any other questions? Anyone? Comments? Great. I can comment. This has been awesome. Got a lot of information in a short period of time. So,
All right. Well, thank you. It's my very first time doing this sort of thing. So today's the anniversary of my first LinkedIn interview. So
there you go. And as I mentioned, it is on the anniversary of the Automation Academy, right? Mm-hmm. So we are 1 year old today. Also, Phil Scruggs is on, and he was my first guest 1 year ago today. So
wow.
Right.
In any case, the next webinar is, as we do this every 2 weeks, December 3rd. And I think, I'm not sure if I'm going to have a guest as such. Well, look at that. It disappeared. But Maintenance and Troubleshooting in Industrial Automation is my new book, and it hopefully will be published this year. And it has a lot of variety of things. I published a book exactly, I guess, 8 years ago called Industrial Automation Hands-On. And this is an improvement over that. That was a McGraw-Hill book, and I had no control over it. So they published it, and I can't update it. I can't change it. It was black and white. It was very expensive, hardcover book. This is a soft cover book with more information into it, and it's going to be about half the price. So that's the advantages of self-publishing. So that's what we'll be doing 2 weeks from today on Friday, December 3rd. And at this point, I'm going to go ahead and end the webinar itself. If anybody wants to hang around afterward offline and discuss anything, I'll still be here. But thank you very much, Ted, and other participants. John, Phil, all you guys. Thank you very much.
Thank you.
Take care. Have a good holiday, everyone.
You too.